Good morning, everybody, or afternoon. I feel like I have to say that now with virtual teaching all the time. Welcome to week 2 of virtual teaching. You guys are watching this on Ed Puzzle. There will be some questions to go along with each one of these different topics. This presentation is going to sound just like the presentation in school when we did our overview of why we explore at the front desk. I'd ask you guys some questions. I'd tell you about some of the topics. I'd tell you to think about some different things when we talk about it. If you guys recall, you answered a question about human exploration, about why you thought it was important, why you didn't think it was important that we continue to explore as a human civilization, the ocean, deep space, whatever it might be. You guys came up with some fantastic answers. And then after that, I told you guys these are the 4 categories of the reasons why I think it's important that we continue to explore. And those 4 categories of reasoning why we would explore is human health, climate change, energy, and ocean health. Now, we can't do any type of exploring without having a boat. So we have the NOAA ship Okeanos. The NOAA ship Okeanos, guys, is all around the world. It goes everywhere on different expeditions, trying to find things to research. Some of the things you see up here on the screen, that the NOAA organization itself was formed in 1970, explores the deep ocean and gains knowledge about ocean life. Some technology. That's what's really important about this. What are the technologies that is on the NOAA ship Okeanos? The very first one that you saw on your screen is ROVs, remotely operated vehicles. There's 2 different types of remotely operated vehicles. There are tethered and non-tethered remotely operated vehicles. Tethered ones meaning that they are connected to the ship in some way, or shape, or form, and non-tethered meaning that they are just free to roam about. Different technology that can also be found on there: telepresence and satellites, sonar using for mapping the ocean floors, and autonomous underwater vehicles as well, kind of in the same boat as remotely operated vehicles as well. Just to prove to you that I did see the NOAA ship Okeanos, you can see those bottom 2 pictures there, me with those awesome blue shades on with my brother-in-law there out on a boat on Virginia Beach, and there's the picture right next to it of the NOAA ship Okeanos, the exact same picture you're seeing to the very right of the screen. So I did get to see that in person, and me being the nerd that I am, was pretty excited about it, so obviously I had to take a picture of it. So that is the boat. Some different technologies you talked about with it, when it was formed, some important things about it. Now we can use that boat to research these 4 different things. Number 1, human health. Human health, guys, we're talking about these things called sessile invertebrates, and we talked about 3 specific things about sessile invertebrates: the fact that they cannot move, they have toxins in their body, and they're found in coral reefs, which is really important because if coral reefs go bad, that means that all these sessile invertebrates are eventually going to die, and we do not want that to happen. Now, how are we using these things that can't move? How do they protect themselves? Remember, we talked about them being able to protect themselves because the fact they can't move. If you can't move in the ocean, and you're something that something else might want to eat, you're probably going to die. So over time, they've evolved the fact that they have toxins in their body so that if something decides to eat it, they die. Now, how does that have anything to do with human health? Remember that we're taking those toxins out of the sessile invertebrates. We're taking a sessile invertebrate, taking a toxin out of it, and we are then bringing that to the lab to check it out to see what the exact chemical diagnosis is of the different toxins within the body. They're putting it into a lab, they're putting it under a microscope, they're checking it out, and they're then using that information to then develop medications to not attack the human body, but to attack diseases within the human body. And a couple examples of different medicines that have been developed are briostatin and pseudohyptarosin, and these are anti-cancer medicines. You have medicine that might be able to eliminate Alzheimer's, that might be able to attack other diseases as well. Anti-inflammation medication has been developed. A litany of different medications have been developed from our knowledge of the sessile invertebrates and the coral reef. So reason number 1, human health, the fact that we want to improve our health in a time that we are in virtual school, not able to be in school because of a pandemic, because of an issue that we are all having. This category should be even more important than we've ever talked about before, because what if there is a cure in the ocean for some of the things that we're dealing with right now? So this is something to really think about going forth. But this is reason number 1 why we explore. Reason number 2, this word climate change. All right, this nasty word climate change. What does climate change mean? Remember, we talked about in class that you can't define climate change without a particular gas. What gas is that we need to be able to talk about in order to define climate change? And that gas is carbon dioxide. So we'll go over the definition of climate change real quick, and we'll walk through all these different categories that go along with it. Climate change, guys, remember, is the steady increase in temperatures on planet Earth. And the reason being, the theory behind climate change is that it's because when we burn fossil fuels that we use in our cars and our houses every single day, we release a gas known as carbon dioxide. It goes into the atmosphere, which then in turn allows sunlight to go through. Sunlight, when it goes through our atmosphere, comes down to planet Earth. It heats up planet Earth. And normally that heat can escape a little bit better. And because we've put so much carbon dioxide into the atmosphere, the heat is then stuck on planet Earth, and we are slowly, slowly heating planet Earth because of that. That is the theory of climate change. Now, the whole theory of climate change revolves around carbon dioxide. Is carbon dioxide bad? And the answer to that question, guys, is no, it's great. It's phenomenal. Guys, carbon dioxide is an absolute necessity. All right. It is something that if you talk to somebody and tell them the fact that carbon dioxide is the reason why climate change is happening, they'll probably say we need to ban all carbon dioxide. Guys, without carbon dioxide, we do not have our wonderful trees. Trees breathe carbon dioxide. Carbon dioxide provides the necessities for life. If you don't have carbon dioxide, we're all going to die. So we need it. Now, here's what the thing is that they're talking about when we're talking about climate change is the fact that we're just producing too much of it in an unnatural way. Okay, it's like saying that water is bad. Water's not bad. People have died from water. They've either drowned in the water. You could potentially drink too much water, and it's not good for you. That doesn't mean we need to ban all water. All right, water is a fantastic thing. Without it, once again, we die, just like carbon dioxide. All right, so carbon dioxide gets a bad name because of its rap with climate change, but it's actually a necessity. Now, there's two different viewpoints on climate change. You have liberals who believe that climate change is completely caused by you, by people. Whereas conservatives believe that climate change is not caused by you, it is mainly caused by nature. Now, what are some of those natural causes? The season fall, one of the main reasons I live in the Northeast, volcanoes, and also solar activity, the fact that the sun goes through phases of producing more energy or less energy, and that's what causes ice ages and heats and droughts and things like that. I want some things for you to think about when you think about liberals, the different pictures and different images that come into your head. Liberals, guys, I want you guys to think of President Obama. Conservative, I want you guys to think of President Trump. So hopefully those images pop into your head when you hear those words, and that'll help you decipher the differences between the two. What are some potential effects of climate change? Potential effects of climate change, guys: polar ice caps melting, sea level rise, mass human migration and displacement, and more frequent and larger hurricanes. So what's kind of cool about looking at those different effects is that they're all effects upon effects. We've talked about the next generation science standards. We talked about those cross-cutting concepts, cause and effect. These effects all layer on top of one another. The polar ice caps melt, which in turn affects sea level rise. Sea level rise then in turn affects mass human migration. I said that in class. Where is mass human migration coming into this? Sea level rise and mass human migration? That doesn't make any sense. Take a second to think about what that might possibly mean. And if you came up with the idea, the fact that humans are mainly living in large populations on the coastlines, you are completely correct. So if the vast majority of the population lives near the coast, when the sea levels rise, we are going to have mass migration inward in order to avoid the rising of the seas. And obviously more frequent and large hurricanes. You can have a great example of that. That would be Hurricane Sandy. We've never seen anything like that in the Northeast before. So those are all some different effects. And now what are some solutions? The main solution, guys, main solution that liberals are putting out there is to completely switch from fossil fuels. That would be oil, gasoline, crude oil, etc. A complete switch from that to renewable energy sources. For example, solar energy, wind energy, all the different energies that we're going to talk about on the next slide. So what are some of those different energy types? We're talking about wave and tidal energy. We're talking about solar, wind energy, thermal energy. Methane hydrates are put onto the slide just because they are coming from the ocean, but they are a non-renewable thing. That picture right here is of methane hydrate. It looks like ice. You can light it on fire. It's actually really cool looking if you've ever seen any videos of it. But the renewable energies that we're talking about are found right here. I'll talk about the one energy that we talked about in class in the same fashion that we did, and that was through Tesla. Tesla has those solar roofs. Remember we talked about that, and the only issue that we really have with the solar roof is the fact that it is super expensive. It's very expensive in comparison to getting a regular roof put onto your house. But the idea is that you have all these interlocking things, and I'll scroll down for you to be able to see how they interlock. They'll interlock just like that. They collect the sun's energy, and in the next image, you're going to be able to see where that energy goes to. There's a little Tesla box on the side of the house, and it's literally just a giant battery pack, and that battery pack holds all the energy. So instead of what you would normally do with solar panels, which is it collects the energy, it sends it back out to the grid, which the power company has use of, and then they send it back to you for a cheaper price. Instead of doing that, all of your energy literally stays at your house. You are completely sustainable on your own energy. So solar energy is a fantastic idea, in combination with other things as well. All right, I'm not going to go through every one of the different types of energy here. You can give them a quick Google. You can take a look at some of the simple things that are put onto this slides presentation. Um, but those are your energies. That's why it's important for us to research, to find these new energies, find better ways to become efficient with them, and then use them and implement them in the US economy. And last but not least, guys, the last category that I'm going to be talking about is ocean health. And ocean health, guys, there's a bunch of different things going along with that. We have overfishing, toxins, marine debris, ocean acidification, habitat destruction, and invasive species. I'm going to talk about two of the different categories, and that's overfishing and the toxins. Overfishing, I'm talking about that. Why? And overfishing, what I'm going to talk about is Wicked Tuna. That's the show that I like to watch, and it's talking about catching these giant tuna. And just so you have an idea what those giant tuna look like, here is a short example of how big a tuna could be. You can see that this is a grown man standing here, and there's a tuna with its head down this way and his tail all the way up here, and it is a giant, giant tuna. So pretty interesting stuff. But how they used to fish those tuna would be through nets, and you would catch not one at a time, not two at a time, not three at a time, but you would catch entire families of tuna. And now the regulations have come in, and now they're only allowed to catch them using a fishing pole. Therefore, the population is increasing, and tuna are well on their way, hopefully, to becoming a much better population of fish. And the last thing I'll talk about is toxins, marine debris, or the red tide. Where I talked about one of the fantastic things that I like to look at is agriculture in the United States, and mainly in the center of the United States, we grow a lot of grains, and in order to protect those grains, we spray them with a lot of herbicides, pesticides. Those herbicides and pesticides travel down the Mississippi River, and they eventually find themselves into the Gulf of Mexico, and you get a ton of red tides in the Gulf of Mexico because of an overabundance of phosphorus and nitrogen in the water that produces a algae effect, and you get this thing known as the red tide. That's definitely something that you can Google. But these are all examples of ocean health, and hopefully that sounded just like our presentation that we did in class together when we talked about it. Answer the questions on Edpuzzle. Hope you guys have a great second week of virtual class, and I'll be talking to you guys later on.